afternoon, and welcome to our last session for today. This is our first day of the conference, and the last session will be the vendor Crossfire. This will be the market analysis that will start first, and then we will have the vendor Crossfire. Welcome all. Welcome to the participants to the vendor Crossfire. I'd like to just indicate that the vendor Crossfire is mainly to honor our sponsors so that they can be able to come and share with us about their technologies in a friendly manner in which we introduce them, give them opportunities to talk about their technologies, but also at the same time, be able to know about their other competitors. It is not really a serious competition, but it's more about information sharing. With us here, we also have got the students who are participating in the student cluster competition. And my job today is to introduce the people who will be driving this session. This is a fast-paced session. And you will see that immediately when you start, you have to have your seatbelt on. So I am going to introduce the driver, Addison Snell. Addison Snell is the co-founder and chief executive officer for Intersect360. Now it's the 15th year delivering forecasts and insights on high-performance computing. And Addison is a competent bridge player, an excellent Scrabble player. I like that in his bucket list, he's dreaming to compose a crossword published in New York Times. Very interesting. Welcome, Addison.
Thank you very much.
And with Addison is Dan Alls, Chief Research Officer. And Dan is a veteran. That's what it says. He's a veteran of high-performance computing industry with more than 25 years. Yeah, that sounds like a veteran. Experience on high-end server market and as an industry analyst. At Intersect360, he's a research chief, and Dan leads the demand side and supply-driven data analysis practice for Intersect360. The rest of the bio is in there, and Dan began his career at Sequent Computing, an early pioneer in high scalable business systems. He was an inaugural lead for the successful server consolidation program at Sun Microsystems, was at IBM. So you're meeting all your colleagues now. Dan and Addison, I think my job here is complete. Over to you. I have to put on my safety belt.
Buckle in, it's going to be a bumpy and fast ride.
That's right. And thank you very much, Happy and Werner and all the organizers. We're always very pleased to participate in the CHPC National Conference. I like it even better when I get to do it in person. I'm sorry that it's been a couple years now that we haven't been able to do that. I look forward to being in South Africa next year when we finally use high performance computing to get this COVID under control. Dan and I both always enjoy it and look forward to it. Thank you for setting up the vendor Crossfire. As you eloquently said, we like to hear from, and we appreciate the vendor sponsors and want to hear from them, but we want to also do it in an engaging and fast-paced and fun and friendly way. So we constructed this vendor Crossfire showdown in order to hear quick presentations from all of the vendors. And then Dan and I put together some toss-up questions that they can all answer. And we've got 3 of our student cluster participants here to help rate the participants. So everyone, you've got to give a clear, concise presentation, answer the questions, and then the students will let you know how you did at the end of the session. So really looking forward to that. I am going to start by spending about 25 minutes just going through our market overview for the HPC and AI market. This will be an abbreviated session of what we've done in our own webinars, as well as insights from the most recently completed supercomputing conference in St. Louis, which was fun to be back in person again. So we'll give a couple of insights from that. Dan will be able to help me along the way. So that's our agenda, starting with checking in on our 2021 HPC market forecast. It's now the first day of December, so we're starting to get a sense of how we forecast the year and how we're coming in relative to that forecast. Spoiler alert, we're not all the way back to where we thought we would be. We also want to give a couple of highlights from our newest completed survey, which was a comprehensive study on software environments in high performance computing. We will give a quick mention of our upcoming Winter Classic Student Cluster Competition. I'll kick it over to Dan for that, and a brief recap of SC21, which is a lot to go through in 25 minutes, but if we can give the vendor sponsors fast presentation times, then we can sign up for that ourselves. This is the slide as we presented it in June for work that we did in March and April, putting together the HPC market forecast. And we're not going to go back through the entire forecast, but this is the slide as it was, other than the highlighted portions, which I've turned red here. We were saying that the HPC market would recover from a down year in 2020 to grow to $60 billion worldwide in 2025. Cloud is, of course, the major growth area and continues at high double-digit growth rates. The big things that we want to check in on is the idea that the HPC market would have a significant rebound in 2021 as the COVID-19 echo effect, sales cycles come back in, a lot of things rebound, and then we get a big growth year. And we also said at this point, that was back in Q2, we were aware of supply side effects from supply chain issues and microprocessors, but we weren't anticipating any full year detriment to the market from supply chain issues at this time. Those are specifically the things we want to look at. This is how the forecast looked as we presented it in June. You can see that bounce back year in 2021, which looks like a very high year-over-year growth rate. That's 16.4%. That's sort of a built-in rebound that happens after a short-term recession, because most of what happens in 2020 or in the year of the recession is you get systems that are delayed, not canceled, and therefore they kind of come back as the sales cycles come back in the next year, and you get a bump forward, and we were anticipating that in 2021. And then you get what looks like still a high 5-year growth rate, and that's where you see the 9.1% compound annual growth rate. That's high because the base year for the growth rate is low, right? And then you have the rebound and it comes back to where things were, and it all adds up to what would otherwise be a smooth 6-year compound growth rate at 7.5%. But one thing my partner and our original chief research officer, Chris Willard, always said that I loved is when you make a forecast, it has to be bound by what's realistic. Reality has no such restriction. And that's just a way for us to say, look, reality gets weird sometimes in a way that goes beyond our ability to forecast it. And COVID-19 has stressed that for us in a way that we can underline, highlight. It's just been very difficult to forecast in a pandemic. So here's where we were earlier this year in the April-June timeframe when we put together this forecast versus where we are today. Back in April, I was feeling optimistic. I was getting vaccinated. We felt like we were heading back to what you could call normal economic activity. But today, worldwide, vaccinations have been uneven, either by geographic location location, or some people, even where vaccines are readily available, some people don't want them. I personally don't understand that, but the vaccinations have been uneven. Then the virus itself continues to mutate, and we're always chasing after it. And the net effect is some industries have not yet fully rebounded back to what we could think of as normal economic activity. Back in the spring, we were aware of potential supply chain issues, but hopeful that they would not have an effect on high performance computing. Today, it's clear that they are delaying some high performance computing deliveries, particularly in the entry level and mid range. And finally, back in the spring, we were anticipating that one US exascale system, specifically with Frontier, would fully revenue in this calendar year. That now looks, I would say, extremely unlikely. I suppose it's possible still that we could get some revenue from Frontier, but it seems unlikely that any revenue would get recognized this calendar year. Now, there are Chinese exascale systems that we've learned more about, but there's a question there as to what, if anything, is the revenue impact of that. And I'll come back to that point in a few minutes. Let's take each of these one by one. The lingering COVID-19 effects. The simple fact is, some industries are not back to what we would call normal economic activity. And some of these are large or significant high performance computing vertical markets that had a major negative effect from COVID-19. The automotive and aerospace manufacturing is probably top of that, and is just simply not back to full speed. Oil and gas, the price of oil has rebounded, but we haven't seen that reflected yet in a big rebound in HPC purchases. Electronics, semiconductors, academia, these are all short of the projected rebound. That they've come up a little bit, but not fully compared to what we would have hoped for in this calendar year. Now, on the other side, pharmaceutical spending has been continuing strong. That's an area where HPC is used to help combat the pandemic. So we need to model this vertical market by vertical market, domain by domain, in order to look at where things really are going. We're going to look at the supply side as well. How well are all of the server vendors, storage vendors, cloud vendors doing in this space? That'll add up to a complete year picture when we put it together in early 2022. It has certainly been continue to vary by geographic region. What's going on in Africa or China or Europe, the US are all very different. Entry level and mid range have continued to be more affected than the high end and supercomputing. The higher up you go, the more stable it is, because those are long-term planned sales that tend to still go through. But the entry level mid range certainly also have more replacement by cloud. Now, cloud can help balance some of this out. Cloud does well with uncertainty. When you're not sure what you're going to buy on-prem, you can push things out to cloud. Supply chain disruptions. We're getting this now from the supply side and the demand side. Several users have been reporting to us long lead times in ordering, delivery, again, concentrated mostly on entry level and mid-range systems, but not immune there. We look at what's gone on with Frontier, and it's possible that supply chain delays have pushed out by a quarter, when the Frontier system would come online. We have started looking at the vendors' quarterly and annual reports. HPE just released their August to October quarter, and last night, after I put this slide together, I went through the HPE deck. They are talking about supply chain issues in their compute group outside of the base HPC and AI, which does still contribute a little bit to the HPE numbers on that. So we're going to have both the end user view and the supplier view on this, and I think what we're going to see is some sales are falling out of the end of this year and into the beginning of next year. And cloud, again, can help pick up some of the slack there. Now, Exascale Systems, like I said, when we built the forecast model, some of these systems are large enough that you really have to account for them individually. Frontier is certainly one of those. It really looks like that's unlikely that any revenue from Frontier comes into 2021. China two Exascale systems that are, it's now well reported that there are two systems at the Exascale level that are in China. But the important thing to recognize here is these systems are built, not bought, which is to say, when we build a market model, it's the baseline thing that we track is revenue, right? How much would these systems sell for? And when a system is built instead of bought, it's tough to determine what revenue, if anything, is associated with these systems. There's no system vendor. There's nothing that was actually sold. We might be able to track some component sales, but we really have to dig at this to figure out how to count it. Another way to think about it is, if Dan and I were doing a market size for fast food markets and adding up, McDonald's and Wendy's and KFC and all of those things, we could say, here's the market for that, but it doesn't count a hamburger that you make yourself at home. It especially does not count the hamburger you make yourself at home when you raised your own cow. Now, you could talk about how much money you spent to raise a cow and slaughter it and process the meat, and certainly you spent money, but it's not part of the fast food market for hamburgers, right? So, we want to be careful in terms of what things we track. All right, so here's our revised guidance. Our original guidance, if you remember that previous picture, we were showing that 16.4% guidance year over year up. Our revised guidance that we put out now, without a specific number, is that we're going to be more in the 6 to 12% year over year range. And in fact, I would say in the last couple of weeks, it now looks like that 12% is maybe out of reach, and it feels more like 6 to 10 to me. But we have to really add up the supplier guidance for this at this time. Now, we're not changing the 5-year outlook at this time, but if we're down at the bottom end of that range, at the low end, the 6%, no COVID-19 rebound, things that we were previously counted as delayed or really lost sales, we're seeing the supply chain issues, that would really be a long-term effect on, we'd have to lower the out years as well. If we get the higher end toward the 12%, that would say that we've recognized some revenue there, limited some COVID-19 rebound. That would be less of an effect on the long-term 5-year forecast. So we're going to continue to monitor that, but this is the second year in a row we've had to put out some revised guidance for the market and say, look, the market just didn't do what we thought it was going to do, and we're off of the forecast. All right, I'm going to give a quick overview of our most recent HPC software survey. This is just following up long strings of surveys that we do on end user ratings of vendors, technology adoption survey, which we're about to do again, budget trends, which go into our forecast. We do those every year. We've now taken a complete look at HPC software across 11 different application domains, plus operating systems, middleware, developer tools. We look at the top applications in those different domains, typical and maximum job scalability, how much affinity there is to cloud, how scalable they are in different processing architectures by domain, how much they're incorporating machine learning. This is obviously not a full presentation, and in fact, we're still putting together the complete presentation for our clients to be delivered in the next couple of weeks. But here's some partial insights here. It's interesting even just to look at operating systems in this space, which are almost all Linux. You see an other sliver there that's 2%, and even some of those are still other Linuxes that are not on this chart. Like, we got a couple of mentions of Cray Linux, which we hadn't specifically called out elsewhere. CentOS is the number 1, followed by Red Hat. That's a gain. Red Hat, there was a time when that was number 1. But what's going to be interesting is watching the transition between CentOS and Rocky, since we're seeing the end of CentOS, and Rocky is going to try to pick that up. I was actually impressed at how many people already said they were making that transition to Rocky Linux. Open source versus ISV versus in-house. This is a trend that we've been watching over the last several years. I can remember this chart being roughly even thirds earlier ago in HPC. And now what we're seeing that we've been talking about the last several years is a continued trend away from commercial licensed ISV applications toward open source applications primarily. In-house has gone up a little bit, but the big thing is we go less ISV and more open source. Also, we're looking at, as we look at that in-house development, what are the languages? What are the tools? What are the compilers that get used there? And the big shift is that we've really seen Python now come on strong as a common the development language for high performance computing. It's just about as common as C and C++, and Fortran it was still there, but it's moving gradually more into maintenance mode and less active HPC development. Typical and maximum job scalability. This surprises some people that, we always talk about these very large systems. I was just talking about Exascale. We talk about Petascale. But what we find is that typically jobs are much smaller than that. And in fact, when we look at typical job scalability and see that half of jobs typically are in that 1 to 4 node range, this is one where after we ran the survey, Dan and I can look at it and say, wow, we should have split out one node as separate from 2 to 4 to see what the difference was there. And then maximum job scalability, more than half the time is still less than 16 nodes for individual applications. You say the highest we run that is 16 nodes or fewer, and only 15% of the time do you get people saying their maximum job scalability for a particular application is over 128 nodes. Top biosciences applications. We just picked one domain to put onto the chart here. It shouldn't be a surprise that BLAST and its various formats are at the top of this chart. This is available for all 11 different application domains we're looking at, where you get a sense of what are the top applications. And what I really like pointing out here is how long the tail is. That it's not really you get 2 or 3 applications that dominate any particular vertical market or domain. Typically what we'll see is, sure, there are a couple that are important, but then there's a very long tail of other applications that go into this space. Cloud Affinity. What this is for every individual application named, and this is nearly 2,000 applications we gathered this cloud data for. Someone says, all right, we run this application. Great. For that application, how much affinity is there to cloud on a 7-point scale from it's always on-prem out to the other extreme, it's always cloud. And what we found is that 84% of the time, someone says, yeah, that application is all on-prem. We don't do it in cloud at all. 1% of the time, it's the other way. We run that only in cloud and never on-prem. And the other 15% of the time, it's some kind of mix from some sort of hybrid mix. Sometimes it's on-prem, sometimes it's cloud. Really, HPC is still primarily an on-prem kind of market. Now, the top domain for Cloud Affinity, business analytics. Maybe not a surprise because it has that enterprise overlap there, but business analytics, the pie chart here is all applications put together. We can do this differently for every individual application, every individual domain, but business analytics has the most cloud affinity overall. Now, this is at the individual application level. Certainly when you go out to the site level and say, look, do you ever run on cloud? Yeah, sure. 2/3 of the time, you find a site that says, I use cloud for some things sometimes. but it's not evenly distributed across all the applications. And then some of the data I'm most excited to go through is at the domain level. This is looking at, I chose scientific research as the domain for this chart. How well do your scientific research applications scale and perform on each of the following architectures? We want to get a sense of performance and scalability on Intel x86, AMD x86, ARM, NVIDIA, AMD GPUs, FPGAs, and not only look at how well, what the perception is, but what percent of time do people say, I don't know, which is also in a sense a negative response, because they're not saying it does poorly, but they're saying they haven't bothered to look, right? And looking at, all right, how does that start to change? Now, half of the market is having an opinion already on AMD x86 CPUs. The other half of the market doesn't know. Now, even with Intel x86, you're saying, 22% are saying, I don't know. That's okay to say, I don't know how well it scales and performs relative to other architectures. But we're starting to see Intel's dominance in this start to diminish a little bit. And we want to really monitor how this looks over time. Current AI engagement, we're looking at how much has, there's three different categories really. The complete integration of AI and machine learning into HPC applications for steering or optimization. That's where you get into AI augmented HPC. Then the next level is we use machine learning for pre or post processing, which is we're doing AI, but it's before or after the HPC. And then there's another category of it's entirely separate. We have HPC over here, we have AI and machine learning over there. Now we're at more than a third of the market is really getting into AI augmented HPC at some level, and half of the market is doing it for pre or post processing, and this is increasing over time. The other interesting thing on this chart is the most common machine learning frameworks that were named in our surveys were just not what we thought they were going to be. And it's one of these where we go, really, did we get that right? And we start looking at the data. It's why we do the surveys. Sometimes our common knowledge that we think is actually proved out wrong by the surveys, and something else comes up that we hadn't anticipated. This is one of those cases. Notes from SC21, then I'm going to let Dan speak for a minute. First of all, great to be in person again. There were about 3,500 on-site attendees, and that's about the size of an ISC conference, maybe a little bigger. And if I thought I was going to have a 50% show based on about 25% attendance, really, I felt like we had about a 90% show. They were really good presentations there.
Yeah, the quantity was down in terms of people, but I think the quality was high.
Yeah, absolutely. And some of the things you and I talked about, I thought one of the big stories going into it was going to be AMD versus Intel versus NVIDIA. That wasn't the big thing playing out at the show. That was mostly a virtual thing. Yeah. AMD had a very strong Milan X MI200 launch prior to the conference. Dan, I love that you said they should have hired a marching band to go around the show floor. And then it was quiet once we got there.
Well, they had 27 people there and maybe one in the booth. And I think all 26 were in whisper suites making deals.
Exactly. NVIDIA also had GTC right before supercomputing, and there they were focused, I think, appropriately on the software ecosystem and how much of a head start they had with CUDA and how much optimization was done there. I thought the most important thing from GTC was the announcement of QNumeric, which is promising to do for Python what CUDA has been doing for C and C++, as appropriate to our previous chart on the common Python showing up. And then Intel, I really liked their virtual keynote that Jeff McVeigh gave. I thought it really set a new engineering tone and started a drumbeat on performance and execution that was different than we've heard from Intel over the last couple of years.
I don't know. Is it just me, or is Intel getting much geekier over time?
I like it. Bring on the geek.
I do too.
I would say I was surprised at how much we did learn about the Chinese exascale systems. You know, they're not on the top 500 list, but they were pretty well described in a talk by David Kahaner of ATIP and in the Gordon Bell papers. There's been some good coverage in HPC Wire describing these systems. But take note, everybody, that the top two systems, both exascale, plus a third on the way, which is delayed. China now has 4 of the top 5 and 6 of the top 10 systems in the world, if you count the ones that aren't listed on there. So China is really in the lead at the apex of supercomputing right now. And a surprise topic that came up for us quite a lot is composability. I think this is going to be a topic for the year ahead.
Absolutely agree. There's a lot of goodness in composability, but a lot of confusion as to just what's possible now and what's coming down the road.
All right, Dan, tell us a little bit about our upcoming Winter Classic Invitational Student Cluster Competition in just a few minutes.
Sure. This is the second annual Winter Classic Invitational Student Cluster Competition. It's the only competition that reaches out exclusively to historically Black colleges and universities and Hispanic serving institutions. What we're going to be doing is teaching these kids and having them compete at profiling and optimizing applications. Some of the ways that we're going to do it are a little bit up in the air right now, but it will happen. And what we're really doing with this competition is we're trying to develop new and diverse talent for HPC. I'm not a young man. I'm not going to be able to go on for another 40, 50 years. I mean, odds are I'll be able to, but probably not. But we also, in addition to refreshing our talent pool, we want to increase the diversity, and this is a way to do it.
Here we have to acknowledge that some of this is from an American perspective, right?
Yes.
That you know what diversity and inclusion looks like in the United States is a little different than it might look in Africa or in Europe. But I will say that this has been locally a major challenge for the technology community at large, and something that we need to address.
And I would be remiss if I didn't say that this was somewhat inspired by what Happy Satoli and all of his gang of thousands have done in South Africa with your student cluster competition.
Okay, so we're going to have a bunch of teams coming from these historically Black colleges and universities, Hispanic serving institutions, and they're going to do the things that student cluster competitions do. We're signing up mentors, we're signing up sponsors. If you want to help, there are ways to do that, right, Dan?
Absolutely, especially if you're an organization that can host kids on a cluster. Hosting all 10 teams on a big old cluster would be fantastic. But please reach out to me. My contact details are there. I'm not too hard to find.
Fantastic. Okay, and there are ways to work with us. That'll be in the charts that I'll go out to everybody. The big thing I'll point out is you can go to our website and sign up to get our newsletters. And I know everyone hates marketing newsletters, but really when we're promoting that stuff, it's, you know, surveys are out and results are out. It might be something you actually want to stay on top of. When we give a free webinar, there's a lot of information that goes out there. Then, of course, you can sign up to listen to any of our podcasts. I do This Week in HPC. Dan does Radio Free HPC. This Week in HPC, I think, is really the more intellectual, better one for smart people. Wouldn't you think, Dan? And Radio Free is kind of lowbrow and no one cares.
That's an interesting way to look at it, Addison. Unfortunately, it's only your way of looking at it. Radio Free HPC is a wide-ranging, highly intellectual, deep podcast, while This Week in HPC is sort of a reading of press releases.
Yeah, okay. Well, you can decide which one you like better, I guess.
But listen to both.
Next up,
listen to both.
Listen to both. Next up is vendor Crossfire. And I was starting to explain where we were with that, but here are our different sponsors of the conference. We have representatives from Intel, NVIDIA, HPE, Dell, and Altair, and you see that intersecting flower diagram there. We're going to go around the horn like that, where each of these companies gets a 5-minute slot to give a 3-slide overview, of their solutions for HPC. They can talk about whatever they want as long as they only use 5 minutes and 3 slides to do it. And then Dan and I will ask a quick follow-up question to the presentation, which we haven't decided on in advance because we don't know yet what they're going to present. So Dan and I have to be on our toes. And we've got a panel of students from the student cluster competition, Jaco Ferreira and Rafiwa Matumba from UWC and Edward Ramashia from WITS will be listening and behind the scenes rating them on how well they think they've done. After the presentation portion, we're going to do toss-up questions where our panelists will go head-to-head, a pair at a time, to answer questions we've prepared for them, and we'll have one final question for everybody at the end. Then we'll hear from the students again, and they can say who they think did the best job presenting and addressing the questions that we've given to them. So this is a fun way for us to hear from all of the vendor sponsors of this event. And why don't we kick it off with our first presentation?
And who will do that?
I think, is Intel up first?
They are now.
I'm on, thank you.
Welcome.
So let me share. Can you see? No, not
Not quite yet.
Should be.
Here it
soon.
comes.
Okay.
So
Your time starts now.
okay, I'm Jean-Laurent Philippe. I'm the director for HPC in EMEA, Europe, Middle East, Africa. And what I want to show you is that the Intel roadmap, which is known to be Xeon mostly for HPC, is evolving significantly. We have introduced the Ice Lake earlier this year with significant performance increase, also a lot of new features like security with SGX. Moving on to next year, we'll have the next generation of Xeon with Sapphire Rapids, which will bring a lot more new features and therefore performance for HPC. But we know also that a lot of applications benefit from GPUs, and we will be bringing the Ponte Vecchio GPU that is targeted for HPC and AI, and that you will see both with the Sapphire Rapids in the Aurora machine. But we know also that we have hit the memory wall and that we need some help on this for the end users to be able to get to higher levels of performance for applications that may not be fitted very well on GPUs and that will benefit from scalar and vector features of the Xeon processors. That's why we're bringing the HBM onto the Xeon processor also in 2022. And we have a roadmap that will go into 23 and beyond with those swim lanes being supported. That's great, but how do we make sure that all of the applications that exist or that will exist and that can take advantage of CPUs and GPUs have their code not specifically for some hardware configurations, but can be very regularly used across different architectures, CPU and GPUs, and even better, across vendors. One API was a standard that we announced and offered at Supercomputing 2019, and that is taking shape as we speak. We have had a lot of success with it at universities and working with governments and standardization bodies, where we have seen also the industry using it. And if it works very well on Intel CPUs and GPUs, you know that it works also with the hardware abstraction layer for the other vendors like AMD, ARM, or NVIDIA. So that's helping with the open standard that Intel wants to support and make available. This means that as we get into next year and the future, we will have the performance to support our leadership message that Ice Lake and then Sapphire Rapids and Ponte Vecchio will be bringing to the end users in an open environment for the development of applications with one API and all of the tools that we make available. And that we also open up with our communication on our collaboration with SciPearl in Europe. And all this will be supported by our manufacturing scalability capabilities that we are bringing with the IDM 2.0 with our network of internal fabs, our external foundry support and usage that we are, for example, bringing to reality with some of the tiles of Ponte Vecchio being done in TSMC, while some others are manufactured with the Intel 7 process, and then our Intel Foundry services. All this will bring the exascale supercomputing for all.
Okay. Great job. You left 30 seconds on the clock. I like that. Nicely done. Nicely done. I guess the question I have is exactly where are you with SciPearl and the European Exascale project? Is Ponte Vecchio going to be the accelerator for that first European exascale system?
We are working with SciPearl and we are working with them on finding a solution where SciPearl can bring some of the European IP into a next generation of products. Clearly, they have the CPU expertise, and we are bringing the XE GPU expertise, the XE HPC GPU expertise. As the development of the platform is underway, clearly they will be working with us on what we have at the moment, which is Ponte Vecchio. Which platform will become the first commercial platform is to be defined, and I don't have any insights into that. But the development is happening on RIA on their end, on Ponte Vecchio on our end, and connecting them together with PCIe Gen 5 and CXL clearly.
Okay. Okay. Well, thank you very much for your presentation. Next up, NVIDIA.
Go ahead, Yossi.
Yossi,
Thank you,
should
Jean.
I share for you? Should I share?
Yes, please. Whatever, please share the screen. Before we start, I'd like to thank our colleagues from CHPC for inviting us. Always a pleasure. I agree with what Addison said before. It would be better to do it face to face. Special thanks to Happy for the 15th anniversary of this get-together of HPC in Africa. One man dream really made it happen.
Yes.
So special thanks to Happy, and every time I'd like to say that. Next slide, please.
Your time starts now.
Thank you. So next slide. So obviously what's happening today that the border between a traditional HPC and AI is becoming blurry by the day. There is diversity of applications, and this requires architectural flexibility. And we look at large simulations, training AI, inference, real-time processing, digital twin. I'll say a word about that. It's a well-known fact that we have key automotive customers who, before they're going to build a new factory, they do everything in digital twin. Down the road, no one will do anything without full simulation. Why spend the money and do something in the real world when you can afford with current technology to complete the whole digital twin, do full simulation, and only then go and build what you want to build. If you look at that, we provide today what we call cloud native supercomputing. Traditionally on-prem HPC, the performance is there, but then the security is not necessarily there, and you need to trust the users that they behave.
In cloud, they give you what we call isolation and protection, but then the performance is not always there. Now it's for the first time, we combine both the traditional cloud into the HPC environment, where we bring protection, isolation, multi-tenants, and application performance. Forget about bandwidth, forget about latency. Eventually, it's all about application performance. And with a special new component, which we call DPU, data processing unit, we're able to do exactly that. Next slide, please. So a few words about the cloud native supercomputer and the DPU era. Basically, the DPU is our ConnectX adapter, and plus the addition of 16 ARM cores, which allows you to do programmable any way you want. And the number one application that we found out is providing our customers bare metal security infrastructure. So think about zero trust. Think about that you can do east-west traffic inside the data center and provide complete security for everything you're looking for, be it bare metal performance, be it multi-tenancy, and be it edge computing. Next slide, please. So what about our latest announcement that this is the Quantum 2, the NDR, which is the 6th generation of InfiniBand within the HPC market. So we started back then with 10 gig, 20 gig, 40, 100, 200, and now for the first time, a full-blown NDR 400 gig InfiniBand is available for our customers. So think about the new switch allowing you to have 64 ports of 400 gig or 128 ports of 200 gig. Think about the ConnectX 7 InfiniBand with 400 gig per second capabilities, and the Bluefield with onboard ARM processor, 16 ARM, 64-bit cores, allowing you to do any kind of programmability on the field. Together, this ecosystem with the cables, transceivers, adapters, and switches provide our customers the full ability to go 400 gig, cut the amount of hardware by half compared to 200 gig, and cut it by 75% compared to 100 gig other solutions on the market. Next slide, please. So who jumped the wagon? There is Mississippi State University, who is already implementing NDR, and then there is Texas University. It's all for National Oceanic and Atmospheric Administration, and we have a great deal of dozens of customers waiting to get their hands on our NDR 400 gig solution. Next slide, please. So in a very quick way, this shows the accumulated interconnect trend that we've seen and the usage of NVIDIA networking in the HPC market. Today, we're at all-time high, where the market chooses by what the market thinks is a good solution out there. And we have today, roughly speaking, about 332 systems out of 500, which are adopted NVIDIA solution. Next slide, please. So I'd like to conclude by the last slide. I'll keep my 5 minutes, but a little bit more of 3 slides. As I mentioned before, CUDA is everything when it comes to a complete ecosystem, a complete software ecosystem. We have today about 2,500 applications across all domains that are supported by our CUDA and GPUs. There are about 3 million developers using CUDA daily, and there are about 13 million downloads of CUDA, which happened until now. A full stack HPC AI platform, which is ready today. A word about data center, we look at it as the new unit of compute.
You've hit your 5 minutes, unfortunately.
Okay, good enough. Make a long story short, the era of AI and HPC combined is now offered by NVIDIA. Thank you.
Thank you very much, Yossi. And you're counting on the fact that our student panelists cannot count to 3 in terms of how many slides that you have. So they will see if you get punished for that at all. It was certainly an interesting presentation. The question I have for you is, with all those different technologies at play, should we be thinking, as analysts, should we be thinking of NVIDIA as a server vendor in this space? Is there any part of the server that you're not designing?
Absolutely, we have no plans to compete with our customers. The bottom line is that we do not work direct with anyone. We work practically with all the OEMs out there. We work with all the software frameworks out there. We have full support for our colleagues from HP, from Dell, or gold sponsors like us. But basically, customer can choose any OEM, any platform, any software framework, and we will support it.
Okay,
All right,
but
thank you very much.
I am going to say you
Thank
are
you.
starting to look suspiciously more and more like a server vendor.
We're
But
now going to HPE. Olivier Blondel is up.
Good afternoon. Let me share. I miss it. Here. This one. Partager. I guess we are seeing my slide, correct?
yes, and your
Okay,
time
so
starts right now.
I had to start, but so first, good afternoon, everybody. Good morning, because maybe we have people which are dialing, like our colleagues from Intersect360 from US. So Olivier Blondel, looking at the HPC for Middle East and Africa. I must say HPC and AI, and you will understand why, but you see touch base on it quickly. I have to start with what we are doing a couple of years ago and still doing now. Exascale, US, EMEA, I go fast. This is something which are publicly announced. Most of them are a mix of technology reaching exascale. So exascale, it's starting from 1 in the US up to 2.5. So some of them that will be deployed. So as mentioned, first one to be deployed will be Frontier. It's work in progress, and we can touch base of the different solution and why is not being published to top 500. What did we learn? Because it's a journey, Exascale. We learned that we need flexibility on the software. We need a customer, even if it's on premises, would like to have a cloud experience because workflows are converged. One system is not dedicated to HPC only. Now, an HPC, as we speak, system is becoming a generic word like cloud. We have to talk about workflows for simulation and modeling, for business analytics, and for artificial intelligence. And we have to be able to manage at a cluster level, system level, because we have to include, of course, obviously all the storage, this heterogeneity. So we must call it hybrid workflows. What we learn also, that to reach exascale and to go beyond, we need something new. So Jean-Laurent talks about what Intel is proposing. NVIDIA, you see, talk about what is coming as well. But we need to make sure that the connection, all of this, is not only a pipe. So it needs to be managed at the cluster level. So we need to manage conjunction, for instance. We need to connect easily heterogeneous nodes, which are not maybe directly connected through interconnect. You have to use internet directly, for instance, to the fabrics. And most important, the data. HPC or AI are nothing with data. So we need to have a clever way to store and have the data accessible for computing. So many ways to do it. Or you bring the compute to the data, so you have a memory-centric type of solution, or you have an efficient way to have the data in a low, let's say, low-cost storage with some tiering process. This is, everybody knows this. An HPC system is based first, again, storage, interconnect, compute, and the software. Storage, luster, or spectrum scale, but more important is this is where the data will be, the most used data will be stored to be accessible very easily by the compute, but not all the data needs to be stayed there. They can be stayed up to a tape library, but the most important that all the data needs to be seen by the end user. Interconnect. This is critical, obviously, and we are moving in terms of performance. Compute, well, or you want a very dense system because you are reaching some level of performance that is needed to have like let's talk about power. 100 kilowatts per rack. So you need to have very dense system, or you need flexibility and build your system as you wish. So we're very solution on that. To orchestrate all of it, the software part is very important when it comes to a scheduler, cluster management, but also compiling libraries, orchestrator, for instance, also, which is now people want to use HPC as a service, even if it's on-premise. So you put the system into your data center and you use it, and you pay only for what you use. You don't have to worry about the technology because we manage the.
Sorry to interrupt.
Yeah,
I'm sorry to interrupt, Oliver, but you hit the 5 minutes. You almost got it all in, but good job. Good job. I guess a question that I would have is, how do you guide customers when to use HPE versus the HPE Cray technologies?
You had a chart up that was showing your HPE side and your Cray side, the InfiniBand and the Slingshot and the Apollo and the Shasta. How do people decide which one to use?
Because the problem is not the system. The problem is what problem we have to solve. And based on the problem we have to solve, we put in place the right technology. So everything depends on, first, the application, the algorithm, what the customer wants to achieve. Then it's also, unfortunately, the data center constraints. And among all of this, we build the solution who fits the customer requirements and will help him to resolve the problem he tries to achieve.
So very much your mileage will vary. It depends on where you're coming from or where you're trying to go.
Exactly.
Okay.
To be open, not to be restrictive.
Very good. Next up, we've got Dell. Kamal is going to present for Dell.
Thank you very much. And impressive sessions by everyone. So I hope we don't count this as first slide.
You've already used a minute.
Don't worry. Yeah.
Okay.
So my name is Kamil Beg. Hello, good morning, good afternoon, and good evening to all the esteemed guests and the student audience from different places. And thank you, Happy, for the chance. The last time I was in a regional public event, it was in South Africa, December 2019 conference. And I'm happy to be here today. And at that time, I was really inspired by one of the ladies from University of Cape Town when she presented how the fields of HPC, data analytics, and AI, they are merging and intersecting. She was a PhD in mechanical engineering, but she was presenting how she could use the HPC infrastructure and this computation of fluid dynamics in analyzing and reaching to a place where we can heal a cardiology system failure. And Addison has mentioned how the traditional HPC is growing into something else by adopting like more of an artificial intelligence fields, the data, machine learning, deep learning, data analytics. This is all very important. My Intel colleagues, my NVIDIA, even my HPE colleague Olivier, they all tackled around the technology. And for me, I want to tackle a very important element, which is the human factor. It's you, the people who are listening and the audience who are listening, watching us. What we are interested is to work closely with you. This is why I wanted to present our innovation lab, how we can leverage the HPC and AI engineering expertise and subject matter experts in certain fields, be it in genomics, in weather forecasting, in reservoir engineering, you name it. How we can work together, we utilize your knowledge, your experience, your feedback into how we can support your future investment. and at the same time, how we can learn from you, how we can make our products better. The diversity of our solutions to cover an end-to-end offerings from compute to using the low latency fabrics, the right fabrics, the storage, the services, and the software space around it. This is what we are interested in collaborating with you. And in order to do this, we have already invested with our customers in building center of excellence across the globe, and CHPC in South Africa is one of the beacons looking into this, and they are supporting us. What I wanted to do in my last slide is to invite all of you to join our community and work with us and help us to collaborate together and be members of such a great community. For any other requirement or any other sales, technical, deep dive sessions, we're all here to help you. I hope that I touched the 5 minutes, Dan. Thank you very much.
You are actually significantly under 5 minutes, and we have 1 minute and 45 left for Addison and I to come up with at least one question, maybe two for you.
All yours.
Addison, any thoughts?
Do you have any specific, can you cite any specific learning for your customers or for the industry in general that came out of the HPC and AI Innovation Lab that you wouldn't have had without that investment? What's some big success that came out of that?
One of the North African engagements, I would say, it was around weather modeling project. And that customer didn't want to, they had a time factor element they need to use in order to, injecting the data and to get the result. But they didn't know the size, how to do it. So with availing our innovation lab, certain people in helping in code optimization and doing the benchmarks, we reached out to the right size when we build the cluster, and actually it was like equal plus what we have committed based on our findings. So this is like a small example.
And we should give you a follow-up question as well, since you didn't use all of your time, and this can be related to the same question that that we asked HPE, which is how do you essentially leverage the domain expertise of the lab to give guidance about which components or which types of systems to select for particular workloads?
That's a great question, Addison. So at a certain workload, this is where, like, we have organically within our organization, we have certain SMEs in certain subjects, be it in genomics or in other domains, but also based on the community that we have established, we could reach to someone like Happy or Paul Kalasia and seek their support and guidance if there is something that we don't know. And this is the whole objective of the community, is to collaborate and learn from each other.
Wonderful.
Okay.
Thank you very much for your concise presentation, for answering the questions. We have one more sponsor presentation to hit.
Thank you
Ernst
very much.
Berger is going to present from Altair.
All right, let's see if I can get my screen share going.
Okay, good. We have your screen share up and your time starts right now.
Excellent. Thank you, Dan. So for those of you that haven't come across Altair yet, our influence in HPC is very simple. We try and maximize the value that any investor and user of HPC can gather from their particular system. Now, for the South Africans in the audience, if you'll pardon me, I'll borrow a phrase from Nashua. I mean, essentially what Altair does in HPC is we save you time, we save you money, we put the user first. I mean, and that's something we've been developing for over 30 years as a trusted HPC provider. And I think much of that comes from our unique perspective that we are also providers of the simulation software that many end users, especially in the engineering space, use. So I think we have a keen understanding of what it takes to use HPC and be productive with it. Now, we provide these solutions in a couple of key areas. Now, the first and very obvious one is workload management. If you have a big system and you've paid a lot of money for it, You would like it to run 24/7, and you would like it 100% occupancy to really get the most value for your money and get your workload through. Over the years, our portfolio has expanded quite a lot. So we have 3 key technologies in scheduler there. That's Altair PBS Professional, well-known classic scheduler Accelerator, which is more designed for high throughput computing, and then also recently Grid Engine. The second vertical where we focus our attention in making HPC more efficient is plain and advanced usability. So this is where we look at the end user. Now, our CTO, which many of you will know, Bill Netzberg, Bill likes to say, if we do our jobs properly, people don't notice the HPC. They just notice their work and their simulations coming through. They don't notice the HPC. They look at a simple user interface with which they can manage the cluster, simulate workload, or cloud burst configuration setup. And that is what we do in this setup. There are various tools there to help you do advanced scalability and usability of the HPC. Monitoring of the system of health and software that goes into it is obviously key. So particularly as far as licensing goes, I mean, many customers and users out there have constraints as far as licensing goes. So we keep an eye on your software licensing and also help you optimize usage of that in the HPC context. I'll come back to that point. And lately also we are branching into looking specifically at storage performance. I mean, there are many businesses that have a key reliance on fast storage. And that's where we have tools like Altair Mistral now that look at the I/O performance of processes in a live cluster and alert the system admins when that becomes problematic or slows down for a particular reason. Last but not least, anybody that does a big simulation will be aware of resource and dependency management. And this is also something where we try and really take the heavy lifting off of the end user by helping them manage their workflows, helping them assign licenses to workflows when they are applicable, and helping them package workload maybe to move to the cloud or to move to alternate data centers with tools that do exactly this. Now, instead of talking just a lot about technology, I thought I'd share with you just a few recent examples where we've helped industry do exactly this and overcome some of their problems. The first key one, and this really comes back, both Addison and Happy has said we need to use HPC to overcome COVID. Well, that's what Johnson & Johnson and their Janssen lab is doing. Now, a key problem that they've had was that over the time that they've started using HPC, they built up various different clusters for different divisions. More than 10 of those are running in AWS. But key point, with various different configurations that each of these labs have used. And they needed a simple way just to manage all of these and get the most bang for buck from their cloud investment in this case. So this is where the Altair Grid Engine solution plus NavOps came through for them to help them scale on demand. So you boot up a cluster when you need it. You don't keep it standing around and burning money, essentially. And each group within the group can have their own particular configuration of cluster that suits their particular workload. The second example is from Annapurna Labs, which is an AWS company that some of you may be familiar with. Annapurna Labs develop all kinds of really interesting compute technologies for specific compute applications, and then these get deployed in the AWS frameworks typically. Annapurna Labs runs several on-premise and EC2 configurations for their workload.
I'm afraid we're at the 5 minutes, unfortunately.
Really?
Yes, it flies, doesn't it?
Don't be mean, Dan. I'll send you a variant of COVID.
I know. I think I've had it, but now we have a question from Addison.
That's terrible.
That was mean. But students ignore that. I'm used to taking a lot of
that was a direct threat against the moderator. That's tough, man.
Close your borders. You never know.
I was interested in the fact that you've got 30 years of software experience. Now, of course, you've had underlying generations of things happening in HPC over 30 years, from RISC Unix, SMP, Beowulf clusters, heterogeneous computing, hybrid cloud. How have notions of workload management, usability monitoring, et cetera, changed over time across these generations of HPC technology? And how much can you really rely on experience as a benefit when the underlying hardware changes?
Look, I'd say experience in this business is being dynamic. This is something, I guess, that we've all learned from COVID, is you need to be highly adaptable. And as soon as you realize there's new technology coming along, software updates, the end user has a different requirement, but that doesn't invalidate the fact that these kind of changes happen incrementally. It's very rare that we have a quantum leap in technology overnight. So I believe that experience is something that builds and becomes valuable as you move with time. Every generation builds a little bit on the previous one, which is where our long time using in the environment and in the industry, I think, does come through for us. You've seen it grow, you've seen it moderate over time and move to different use cases. So yeah, I believe growth and moving with the industry is the key thing that helps us.
Excellent. Thank you very much for your presentation. And everyone still has a chance to talk more. We're going to start doing toss-up questions, but before we get to those, I want to check in with our students, see if they're still awake. Yako, Rafiwa, Edward, are you still there? How's everyone doing so far?
Yeah, we're still here.
What are your thoughts, impressions? You've seen 5 of the biggest and most important industry vendors present. Any thoughts?
I'm still busy processing, but I quite like them so far.
Excellent, excellent. Any of the other students want to chime in?
Yes, I'm not very familiar with. I'm very familiar with Intel, NVIDIA, as well as Dell, but I'm not as familiar with HP and Altair. And yeah, I'm very impressed so far with all of them.
Very good. Very good.
All right.
Yeah,
Go ahead.
No, that's all for me.
So you're good right now?
Yeah, I think they were they're pretty good. Yeah, that's
okay. Well, that was our halftime. That was the halftime show. Now let's get
to our first toss-up question. This will be Intel versus NVIDIA. Processing elements, specialized or standardized? What is the proper balance between specialized processing elements that excel at a narrow range of tasks versus generalized processing elements that are suited to a wide range of tasks? Intel, you're first on the slide. You go first.
Thank you. As you know, we have been integrating more and more features into the Xeon processors, and we will keep on doing that. Yet, we don't want to integrate absolutely everything. So for sure, there will be some specialized features that will stay outside. But we believe that Xeon, with its capabilities like AVX512 and soon to come AMX for the matrix multiply, will be giving all of the users the right level of performance and capabilities that they need for, let's say, everyday HPC. When they need to do something very specialized, then they might be needing some accelerators that would be outside, like FPGAs or GPUs, and we are bringing that to our portfolio with all of the tools that will make it easy for them to use.
Yossi, what are your thoughts from NVIDIA?
So it looks like that we don't need to choose. Why not use both? And the answer is simple. A CPU is doing a fantastic job, one job at a time, trans application. When you need accelerated computing, no one can do it better than a GPU. Now, how do you manage those both? I think the answer is the DPU, which we described, the data processing unit. So the DPU is going to call on the CPU to run the application. It will offload the CPU completely with anything which has to do with security. It will call on the GPU to do the accelerated computing. And altogether, here you go with an ultra-modern data center where the data center is the computing unit.
It interests me because we've been watching both Intel and NVIDIA diversify a little bit over time. Intel with its XPU strategy now incorporating different types of processing elements, and NVIDIA spreading out from GPUs into DPUs and potentially ARM CPUs. It's going to be interesting dynamics watching both of these at play. Any other words from both of you on either of you on this topic?
I think maybe one point is, as they all say, it's all about the software. And we're looking at ourselves as a full stack software company. Here comes a customer, he wants to do whatever has to do with HPC or AI. The framework is there, the libraries are there, the CUDA is there, it's easy, the software is there.
Thank you very much for your participation. Dan, do you want to hit our panelists with our next toss-up question?
Okay, HPE versus Dell, you're up on deck. Title here, the value of a server. Both HPE and Dell have the same components to select from when putting together offerings, as do other vendors. As an HPC system provider, where can you and where do you add value to the customer beyond the assembly of best-of-breed components? And HPE, you will go first.
Thank you. It's what we say, understand the customer requirement, his needs, his objectives, his requests, his timeline to put in place the best technology altogether. With experts, unfortunately, I didn't have a chance to show my last slides, but resources, which is research labs, competency centers, Digital Life Garage based in Dubai, which is an incubator when startups, people with ideas, customer, vendors, partners are meeting together to solve a problem bringing by a customer. This is how we tackle HPC. So as you said, and then we put all the pieces all together to make it happen at the customer level. And we, of course, it's not just to make it happen, is during the lifetime of the project, of the system, is always be with him, to collaborate, to extend his first problem by developing his capabilities to address much more problems.
Okay, very good. Dell, response.
So our vision is about how we can keep contribute to the human progress. Hence, we followed, like since day one, an open standard policy where we can go and bring the build blocks to deliver solutions for customers. We make those economically viable in collaboration with all these esteemed technology partners that we work with. In all my 22 years plus of career, I never put a product as my center of universe. It was always our customers. They are the center of our universe, and we plug things around them to enhance their competitive advantage. Before, competitive advantage was a strictly corporate term, not anymore. It applies to nations, it applies to academias, it applies to everyone. So in order for any nation to have a competitive advantage, science and how we can empower that science with our technological offering together as partners, I believe this is what would it take.
I really appreciate the views from both of you. HPE and Dell are the two leading system providers across high-performance computing. Thank you very much for answering our questions there. Question number 3 is Altair versus Intel on the topic I mentioned earlier of composability, which Dan and I were hearing a lot of at supercomputing. What will real-world composable infrastructure look like for high-performance computing customers in the next few years? Ernst from Altair, you're up first on composability.
Oh, that's a good question. I guess taking a leaf from Yossi's book, it could be anything. It all depends on the software eventually. From Altair's side, doesn't really matter. Tell us what software needs you are, and we'll bring you to the right hardware.
We're asking you because you're from a software company, you know, so we thought you'd have something to say about it.
And I think, won't Altair be critical with your customers in performing that composability and using the hooks to compose things?
It may be. It may be. Look, from the simulation perspective, you could, but these things typically hang on various phases of solution that eventually all tie up. It doesn't usually make sense to break them apart. So no, I wouldn't say hooks into the software might make a big difference.
Jean-Laurent, back around to Intel, your views on composability, what it'll look like.
So first, Intel is providing ingredients to solutions. Ingredients include hardware, including, of course, CPU, GPUs, and some fabric solution like we have at the moment, Ethernet and Optane, etc. Each time we bring something new, we also bring some tools and some capabilities to use all of this through software. But as I said, always through an open solution so that it does not tie up the end user, the developer, with or to a certain vendor. And for me and for us at Intel, composability means choice. And I tend to agree with Ernst on that. But we bring something that is easy to use, ubiquitous, and that will help the end user use their systems today and tomorrow so that they have a line of sight of what I do today on software, because some codes have been around for 30 years and might be around again for more. They can still have a view that they will be able to, how would I say, port them or make use of them on the current and future systems.
A chance to advertise CXL goes by the wayside, but I'll get that in there for you. All right, Dan, set up the next one.
The next one, NVIDIA versus HPE, the old HPC. Do you see any ongoing opportunity for use of HPC without AI being included in the mix? And this is going to NVIDIA first.
I think that's a great question. I think sometimes the answer is gray. In this case, it's a black and white. Absolutely, the future is combining AI into HPC. Let me quote James, and I have the honor to quote our CEO. And he said in the keynote, the most significant, the most powerful driving force of our time is artificial intelligence. What could be better than harnessing AI capabilities into the beautiful HPC community?
Okay, that's a pretty strong stake in the ground there.
No old HPC. All HPC includes AI.
Fully agree with Yossi, except that to some extent, I hope that the AI future is not going up to Skynet. Huh? That's my hope, only hope. So we need to put guidelines and borders to stay in control. But fully agree. Workloads, it's hybrid. And I'm adding modeling and simulation, business analytics, and AI all together. And we need to build solution systems which are tackling all of this into for one customer. That's the future.
Okay.
Excellent. Thank you very much for that. We've got our final toss-up question. I got to get back into presentation mode. There we go. All right, back around to Dell and Altair system software, specialized or standardized. We had a hardware question on specialized or standardized. This is the software version of the same question. With regard to system software, middleware, and tools, how much should already come standard, already installed in the box, versus the users selecting individual external tools to fit their needs? And should these be point products or complete suites? Kamal, we're going to start with you at Dell.
Me commenting on this, I have a very friendly relation with our friends at Altair, and at the same time, I'm a big promoter of open source whenever it's available. So with all the, so I like that. So what we see today, the management layer of those systems, we need to see like major evolution, and we're seeing that. Before, either we strictly have to use a bare metal type of HPC software to manage, or like a small virtualized environment where you can go, but you're limited by the barriers of the node itself. Today, we're seeing great effort happening to enhance this type of management tool, where dynamically you can allocate the resources you need for the type of workload, whether it's a traditional HPC workload or it's an AI type of workload. On the application layer, definitely the end users, they have the bigger say in terms of choosing what type of applications they need to do. Emphasizing on the tools below, it's becoming less and less relevant to the end user, but mainly to the people who are managing. Especially now, we're seeing a tendency toward offering HPC as a service. So the tools will never be relevant anymore to the researcher himself. It's a burden taking off their shoulder. I hope I've given my point of view.
Ernst, this is kind of set up for you a particular way. What are your views on specialized versus standardized software for high performance computing?
Yeah, look, I agree with Carmel in many ways. I mean, he said it earlier when he spoke on one of his earlier questions, is the customer really is the focus here. And you need to find what suits any particular use case. I mean, that's essentially what we try and do with our whole suite of the technologies is firstly, take the user to the correct hardware. If that's something you have on site, that's what you get for that particular application. So yes, maybe it is a specific piece of hardware, maybe it's not. That doesn't, that shouldn't hamper the end user's performance. As far as it goes for scheduling that workload, I mean, that's what I sort of mentioned earlier in flow management is pick the right piece of a job and send it to the correct piece of hardware or schedule the correct software license. Whatever the user really needs to solve a problem is what they should be getting. Again, also as Carmel indicated, if we do our jobs properly, the end user stops seeing the HPC and starts seeing their jobs. And that's it.
Thank you very much. We've got one more toss-up question for the whole group. Dan, do you want to take it?
Yes, I do. Today and into the future, let's put ourselves 10 years from now into the future, maybe another CHPC event. When we look back at this time in HPC, what will hindsight show to be the trends that mattered and made a difference in the future? And let's go ahead and start with Del.
Whoever you want.
Whoever's got a question, who's got a quick answer, jump in.
Actually 2 weeks ago, I was reading some Gartner quick trends of this year, and they interestingly I saw like the immersion of IoT towards Internet of Behavior. Today we're like, we've been our data, our actions, it's everywhere. Anything that we wear, be it our watches, our mobiles, or anything else. Today, it's not about Internet of Things, it's about Internet of Behavior. How we as human beings, we contribute to the exabytes or zettabytes of data being generated on a daily basis, and that influence the future. I do remember, I was born in 1970, and when I was watching the Star Trek or stuff, and that small TV, and you're communicating with someone sitting on Mars, it's happening today already. The teleporting, and I don't know. I would never say anything is impossible. So,
all right, teleportation. Okay. That's an interesting one. Who else has an idea of what are the technologies today that are we're gonna look back on 10 years from now and say this is what the important trend was?
I think we can add that as time goes by, there's just too much, and we won't be able to do stuff as we used to do efficiently in the past. We're looking today at a globe of closing to 10 billion people with dozens of billions of products and services. When you do your typical search and you want to find something, the ability to really find what you want is not really there anymore. Imagine that there is a powerful AI engine who knows you much better than you know yourself. And we're talking about a powerful recommendation system that will help you get what you really want that suits your needs. I think if we look back, it's all about becoming a commodity. AI, HPC will become a commodity, and we will use it without second thoughts.
Okay.
Jean-Laurent, you looked like you were about to chime in before.
Yeah, absolutely. So, AI, we are on the third wave, and until now, we've not been able to do really much with it. It's happening. It's started in the past few years, let's say 5+ years, using the HPC infrastructure. I believe that it's going to keep on working together seamlessly between HPC and AI so that the workflows keep on doing some simulation and then do AI to redefine or refine some of the parameters, extract some information, and do that on a seamless basis. I think that whether or not it will be an AI infrastructure that we will have in the future or an HPC infrastructure, they will both coexist with probably, I agree with NVIDIA, a lot more being done by AI.
If any of you just felt an earthquake, that was Intel agreeing with NVIDIA. Ernst, let's go to you next.
Chilling.
Yeah, I think all of the presenters have sort of said it. At Altair, we've got the concept of convergence. So at the moment, we're talking about the development of new technology infrastructures for the compute, for the middleware, for AI, for big data. These things are going to converge. Whether your simulation software is going to depend on all of those, your compute infrastructure is going to offer all of those, and you put them all together and you see how they come together, and it's going to be a simple infrastructure in the future for somebody to ask a question. A little like Yossi said, it's a smart system where you can pose a question, and much of the setup in terms of these different technologies will be invisible to the end user in the end. It's going to be a beautiful converged environment where you can ask your questions and do your science without worrying about how to hook it together on either software or hardware level.
So a vision of simplicity and transparency for you.
Yep.
Olivier, last word's going to be yours. I'm going to try to keep Dan from cutting you off. Dan, don't be rude. Let the man speak. Go ahead, Olivier.
15 seconds.
Yeah, it's fine. 15 seconds. Wow. Three words: hybrid, flexibility, and efficiency. Hybrid, again, many of you talk about it, which is HPC, traditional simulation, AI, business analytics, all combined in one unit. And the challenge is orchestration to make it easier for user, and not only HPC engineers. All users, humans, need to use it. Flexibility. Well, why having all the data collected by sensors, cameras being sent to data center? We need to bring HPC or AI at the edge and to send only relevant data. So we need HPC and AI being out of the data centers, okay? Flexibility also on how to use it. You talk about cloud, but the major issue of cloud is data. Data, it's the IP of companies, needs to remain on primes. So why not bring the cloud into the customer prime, into the customer data center? Efficiency. Well, before that, I was a potential colleague of Yossi. We cannot increase the power consumption of our system. So we need to do better with what we have today in terms of power. That's key.
Those are some really good points. Good job.
I'll tell you what, as
you.
we head into the conclusion of this Crossfire session, Happy, you're right. This is fast paced. This is fun. But I look at what we packed into these presentations and the kind of conversation we got to have with really the leading companies from high performance computing. This is really valuable for me as an analyst to get to sit back and watch it. I'm really grateful to all the participants. Now, before we go, we got to check in with the students who've been diligently taking notes on everything that they've learned. What are your conclusions?
Unmute
Let's
yourself,
go over to
students.
Jaco, Rafiwa, and Edward. Any thoughts? How'd they do?
I think they all did very well, in my opinion. We're still busy discussing about the second half. We have a winner for the first half.
Keep us in suspense. Don't give it up yet.
We will not. Yeah, so I think they all did very well. But we will reveal our results soon.
All right, so
Okay.
I should keep talking while you discuss the second half. All right, so what they've been doing is rating everybody behind the scenes on who they thought gave the best presentations, answered questions the most clearly, and they need about another minute to discuss the second half. I think their plan is to give a first half winner on the presentations and a second half winner on the toss-up Q&A.
I gave them
and
a simple 1 to 1200 scale.
And then I also, during my presentation, saw a couple of questions come into the chat. I'm happy to stay on beyond the next minute to address some of those. And also, if there are any of the vendors who felt like they got rudely cut off by Dan and wanted to finish any point that they made earlier, I'm happy to stay, but it's morning here. I got the whole day in front of me. Everyone else is probably at the end of the day and ready to be done. Let's go check in again. Jaco, how are we doing over there? Are we ready to announce anything?
Just waiting on Edward for his.
Edward, come on, man. Get
Come
with
on,
it.
Edward.
Dan and I had to think up our stuff on the fly.
Should be done in a minute.
Well, again, it's the 1 to 1200 scale.
All right. Happy,
14
anything you would
different-
like to say in conclusion?
They can just give the winner to be Intersect360. You guys.
No, clearly not
No.
us. We had the easy part. All we do is get to poke people. That's fun.
Yeah, no, you did a great job. I think everybody did very well. This was really very informative and interesting show. I'm hoping Werner did record this at Addison and you look at it. I think you really would enjoy it.
Yes, it is being recorded.
It says recording.
Yeah. No, good show.
Edward? Jaco? Do we have verdicts?
Rafua?
Not yet.
Okay.
Edward's busy typing. Almost. It should be
Real
almost done.
quick,
Get the little dot showing up.
let's answer one question, Addison. Somebody happy. Oh, we have something? We have results?
All right, I'll go back and answer one of the questions, which was why didn't the Chinese Exascale Systems go onto the top 500 list? Well, I mean, let's start by saying I don't know. But the rules of top 500 have always been you have to submit your LINPACK score to get on the list, and they chose not to. It's not the first time that we've had industry leading supercomputers not go onto the top 500 list. I can think back even to an American system, the Blue Water system at NCSA was notoriously never listed on the top 500 list. The leading theory with regard to these Chinese systems has been that they've been leery of any political backlash, particularly with regard to export regulations from the United States, if it becomes clear that China is becoming dominant in supercomputing. I'm less of a believer in that with each passing year because the systems are known out there. It's not like they're secret anymore at this point, so that shouldn't be it. And besides, B, we've gotten to where these are now entirely built with Chinese technology, as Dan has pointed out, from a standing start from 7 years ago. So they're somewhat immune to that. A second theory I've heard is that they're just not that interested in that particular metric as opposed to other things like Gordon Bell Awards. This would be akin to saying, well, which do you care about, box office at the movies or Academy Awards? They're both valid. There's not one that's right or wrong, and they could just be in a different metric of success. My own personal theory is that it's not a Chinese list, so they don't care about it. It's very easy for them to say that's not an important ranking to us. We know where we're the most important, and they have their own China 100 of their own Chinese supercomputers that's maybe more interesting to them.
Well,
but I guess we don't really officially know. Go ahead, Dan.
I guess I would say, and sometimes you get 2 or 3 opinions for the price of one from us, is that they were able to, by doing the deep leak, to have their cake and eat it too. They were able to get the glory of having 2, soon to be 3 exascale systems without having to go through all the disclosures required by running a LINPACK. So we don't know the exact configurations. We probably will at some point, but they weren't forced to release those like they would with a LINPACK disclosure. So I think that this gives them the best of both worlds.
It does let them control the narrative. And remember, China is not exactly a freedom of expression country. So this controls the narrative on their terms. All right.
Late breaking
Rafiwa,
news.
Edward, Yako, where are we at? You got to give us some winners here.
We've
We're all
got some
dying.
stuff. And by the way, they're going to do a first and second place for each category. So,
Oh boy.
who wants to announce it on the student side? Come on, somebody unmute themselves. There we go.
I'll do it.
So for the first half, the presentation part, what do you have?
For the presentation part, for second place, we have Dell.
Nice job. Congratulations, Dell.
Who presented a very good presentation, understandable and yeah, understandable and easy to keep track of what's going on. And Altair won first place.
Altair, congratulations.
Congratulations, Altair.
Despite being cut off so rudely.
Yes,
Dan is the worst. Dan is the worst.
I'm going to guess that I helped you, Ernst. If I hadn't cut you off, you would have just lost points continuously.
Sympathy vote. I'll take it.
All right, how about the second half, the head-to-heads?
For the Q&A session, we have gotten second place is a tie between HPE and Altair.
Okay.
And first place was NVIDIA.
Really? Okay.
Yes.
For the solid stake in the hand.
You got your A game today.
Well done. Well done, everybody. Those prizes mean absolutely nothing, although you can use it to brag the next time you have lunch with your colleagues.
There will be no certificate or trophy in the mail for any of you.
Nothing.
So
But we appreciate that everyone was listening and paying attention. I enjoyed the whole conversation.
So now that things have announced, and we don't need anything from you, Dan and Addison, I'd like to commend both of you for how professionally you run it year after year with good questions and organizing it. No, I don't agree that it's easy just spoken. It's not easy to organize everything and put smart questions. I salute you.
Thank you.
Thank you, Yossi.
Thank you.
I appreciate it. We love participating.
And that may have gotten you another award if you'd have said that sooner.
I'll send you a personal award for that. No problem. We love this conference, and Happy and Werner and all the organizers have done such a stellar job of it. You know, Dan and I are Americans. We're here on I'm here on a beautiful sunny day in Northern California now, but this is a global industry. And the face of high performance computing as it develops in Africa is very important to us. As I said at the beginning, I really hope that we get to participate in person next year. This is an important event for us, and we're delighted to support it.
Thank you. Thank you very much. Thank you very much, Addison, Dan, all the colleagues and students, judges, and I would like to thank also the participants and listeners. Thank you very much. And this was the end of our day. Unfortunately, we're not going to have a bride, but that's what I'm normally used to after this show. But next year, Addison, I bet he's going to be in the Kruger.
Yes.
I'm all hungry for kudu. I want to eat some kudu.
And have some of those South African drinks.
Addison, let's be politically correct. Let's allow the kudu to keep on, being the wild, and let's eat a good black angus, and we're all happy.
No, I'm eating the kudu.
I'm going with both, and I'm going to wash it down with a whole bunch of alcohol. So
there we go. Next year is for you guys, and keep the same performance. And I know you guys are even going to outsmart yourself next year. Always a pleasure.
Thank you very much.
Thank you.
Guys.
Thank you.
Thank you very much, everybody.
Thank you. Bye-bye.
Bye-bye.